Alright, we're going to get started wiring this. I'm going to start with the switches. This has a lot of switches. I think I counted 25, and that's not including these, which I don't believe the MCP for the 737 uses, but you could potentially set that up to sync your heading, things like that, if you had a use for that and maybe a different installation. Because of the volume of switches and the number of pins that are available on a Mega type board, I'm going to multiplex. These are little multiplexers. These are pretty cool. These allow you to address 16 channels using 4 pins to address them plus 1 to read. You can also chain these together, so for the cost of 1 more pin, you would get another 16 channels. The negative side of this is that there's additional processor load. Instead of just reading 1 pin, we have to digital write to 4 different pins to set the pin that we want to read. Then we have to do the read. So there's additional load on the processor, but for this application it shouldn't make much difference. For this build, I'm going to use this Key Studio Mega board just because it kind of looks cool. This is a Key Studio board that you can put headers on and make your own shield. This will allow me to easily solder to the pins rather than just poking them in there. This is how I plan to proceed with the build. You can do it many other ways. This is what's going to work for me. I like this because I can solder directly to these pins that are mapped right there next to them, and then if I have additional components I want to build, there's space to do that. We'll see how that progresses over time. This is just going to be built into the panel here somewhere, maybe like there. This is a 1/2 size breadboard. I like the Electro Cookie brand just because I like to say Electro Cookie. But this is essentially the same thing as your regular breadboards, but solderable. So I plan to use this as a backplane for positive and negative power, and also to attach components as needed. We won't get to that, I don't think, in this video. We might use we'll probably use the back planes for the ground and positive on this in this video. Here's some regular solid core hookup wire. This is 24 gauge. I'm almost out, but I have more coming. This is an example of the KD2 switches that are currently built into here. I'd like to talk about this a little bit. These have a bunch of pins on the back. If this is the front of it with the light on the bottom, on the back here, this would be the positive lead for your LED. This would be the negative lead for your LED. We're going to power the LEDs later. This is a common position for your switch. I think this is normally closed and this is normally open. Let's verify that with a meter. I've got this set to beep when it connects. So if I connect one side there, so with this side, with this pin connected and this pin, we should get a beep until we press the button, which will turn off. It means it's normally closed. This one, we should get the beep when we press the button, which we do, so that confirms. So my plan is to wire all my grounds to the one here that's labeled 0. You can use either side. We don't need both sides. This is a dual pole, dual throw switch, so I'm only going to wire my grounds to this one side. I'm not going to do the LEDs just yet because those are going to work differently, and they'll be common positive. My plan here is just to run one wire to all the places that need to be grounded. So we'll hit all of the switches, including these momentary switches. I'll probably hit the middle pin on the encoders as well while I'm in there. This thing, I think we just ground the one pin in the middle. The other thing in here that needs to be grounded is this multiplexer board. Alright, so all we can do is just get started. So one thing I like to do once I make my first connection, when I'm ready for the next one and I get the routing right, I'll make a small little gap in the insulation. Like that. Solder that on and then move along. So I'm going to go ahead and get started on this. Got my handy dandy Hako, I don't know how to pronounce it. I like to solder hot. This is in Fahrenheit, but I set 850 degrees when I solder, but I like to, if you can get away with this, and it allows you to get in and out of your connection quickly without melting things. It's actually better to solder with a hot gun if you're careful about it. Alright, so it's time-lapse time. Alright, I think I got all of the ground planes done. I'll tuck these away, maybe hot glue some of them down. I'm sure that you can do a neater job than I did. I encourage you to do so. If you don't like my technique, you definitely should not use it. But it looks to me like it's going to work. I decided not to do the encoders for now. We'll catch those when we're doing encoders. I'll leave a little extra wire here. This will be the first wire on my backplane. On this one, I'm connecting my grounding backplane to ground here. We have 5 wires that need to go to the Arduino. I'll mount it onto the shield when I'm ready to do that. But first, I'm going. This is going to be multiplexer 1. I'll probably end up using 2 multiplexers in this build. We'll just hook up this one today. All the pins C0 through C15 need to be hooked up as per how they were assigned in the code. I'll put that up on the screen there for you. So I think most of these I mapped in the code to kind of work from the top across, left to right, something like that. Looks like the first one that's mapped is this one. Changeover is position 2, and so on. So you have to look at the code or the schematic and then run wires to each one. I think my multiplexer 1 is going to live right here. I'll probably put spacers on it and mount it there. I'm referencing the code and all of the pins that I have assigned to different functions and buttons on here. I like to use solid core wire for this purpose. That way you don't have little strands. Time-lapse time. So I got 16 switches hooked up to the 16 locations on the multiplexer. I'm going to hook the signal wires up to the board as well. You can see them in the schematic. I'm using pins 3, 4, 5, and 6 for signal 0 through 3 on there. I'm going to go ahead and hook these up, and there's no reason we can't give this a try. I've run power. The Mega board is hooked to the back plane there via one more time lapse for you with whatever royalty-free music I thought was appropriate. I think if I were to do this again, I might pin these onto here just to make it a little bit neater, but it is what it is at this point. I look forward to seeing how you guys build yours. But that's not so bad. I'm going to plug this onto here. So my Arduino board is connected. You can see it's on COM 3. I'm going to go ahead and send my initial program here. So far we're just doing switches. You can see the pin mapping on the switches and then the data refs and commands that it affects. This is really all the code that you have to put in. It's pretty simple. Looks like it's in there. Let's go ahead and start Xplane. Alright, I have Xplane loaded with the 737 up there. You can see as I try different switches on the panel that we just built, it seems to be working just fine. This has both multiplexers on. All of the switches are hooked up right now except for the rotary switch. When you're testing, you can go to the Xplane or the XPL Pro status window here. It will tell you everything. It's the last thing that it saw happen. So you can make sure all your buttons are working. I think they all work. Let's disengage. So all of these drawings and all of the sketches, the Arduino sketches, will be available on Patreon, also on our Discord channel. I would highly recommend you find us on the Discord channel, and we can discuss the build there. That will be best. In the next video, I'm going to go over just quickly the code for XPL Pro, how the sketch works, pretty basic, and then we'll start hooking up the display LEDs. I look forward to seeing you there. I'll see you in the next video.